Hello everyone and welcome to my channel. So first of all, I would like to say that I am a flat earther, so welcome to the non-rotating, non-oblate spheroid. But seriously, I'm making this video because people have been asking me questions because I put on some YouTube videos that the reason things fall is because of density and not gravity, as that's what I believe. I believe that I can possibly prove that. So I was going to originally upload a video about how it was density, but then I thought I can't be the only one who's had this idea, so I decided to YouTube gravity is just density, and I came across a video. I sent this video of the levitating balloon to a commenter, and they was like, "Oh, you sent me an Eric Dubay video." Like, I don't care who it is. I don't know who that is. The point is to look at the content of the video.
What can you bring to it that
But
nobody else can?
obviously now I know who Eric Dubay is, and I've subscribed to Eric Dubay now.
Hey, maybe in 20
and
years
it is just density the reason that things fall. So, like Neil deGrasse Tyson would say this falls because of gravity, because mass attracts mass. I say this falls because it's more dense than the air surrounding it. So, helium, for example, that rises. Why does it rise? Because it's less dense than air. You can have, I can prove that it's not mass attracts mass, because you can have as much mass of helium as you want and gravity will never attract it. So it doesn't really matter the amount of mass of helium, it will never be attracted to the earth. In fact, the more mass of helium, the better if you want to make an object float. So it's not mass attracts mass, I think that pretty much proves it. The video with the balloon levitating I will link, as well as other videos. So I have been both a flat earther and a globe earther several times over the past few months.
Sam, watch your mouth, all right?
I believe that I am a total flat earther, especially believing that gravity doesn't exist. I mean, I think I've pretty much proved mass doesn't attract mass, so if gravity doesn't exist and they say gravity is why planets are spheres, then if gravity doesn't exist, then that's not the reason that they are spheres, and maybe they aren't spheres, or at least the Earth isn't a sphere. People ask me, well, why doesn't the object go up? So, for example, why wouldn't this rise to the less denser? Well, it doesn't want to rise to the less denser. It wants to go to its own density and away from the less dense air. So, there's a video which shows a balloon going left and right. There's actually two that I can link. And it's because if the air is this side, the helium balloon will go this way, and if the dense air is this side, then the less dense helium balloon will go this way. So it does depend on density. And it will go left and right depending on where the density is around it. Okay, so if it is a gas, my original equations didn't work out, so I had to come up with some new ones. So for a gas surrounded by a gas, I came up with, obviously density is normally P, but I've represented it as a D, as I think D is easier because it's density. So if the density of the gas is less than the density of the surrounding gas, then it will float. If the density of the gas is more than the density of the surrounding gas, then it will fall, and if the density of the gas is equal to the density of the surrounding gas, then it will float. So those are the equations that I came up with. For a liquid in a liquid, obviously we all know the density tables. So you've got the density of the liquid. If it's equal to the density of the surrounding liquid, it will mix or stay there. If the density of the liquid is more than the density of the surrounding liquid, it will sink. And if the density of the liquid is less than the density of the surrounding liquid, then it will float or rise. For a solid, again, if it's more dense in, say, the liquid of the sea, for example, then it will sink, and if it's less dense, it will float. But then you will get stuck then, because then they ask, how does a boat float on water? Well, for that, I came up with this equation. So the ms is the mass of the solid, so that would be the mass of the boat. The dsl is the density of the surrounding liquid. the VS is the volume submerged. So if you do the density of the surrounding liquid, so that would be the water, which is normally 997 kilograms meters cubed. So if you do the density of the surrounding liquid times the volume that's submerged, it will give you the mass of the liquid dispersed or the weight of the liquid dispersed, because mass and weight are the same thing, which we will get to in a minute. So yeah, if the mass of the solid is more than the density of the surrounding liquid times the volume submerged, then it will sink. And if the mass of the solid is less than the density of the surrounding liquid times the volume submerged, then it will float. So those are the equations that I came up with. I believe it will work. I have no doubt.
I just want to be able to do anything I want because it makes me feel alive, as opposed to giving me the appearance of normality.
Whatever that means.
I don't think it means much.
Just have a few notes written down.
I'm kind of waiting to do that.
So
Yeah. Is that a compliment?
Do you want to be weird?
I had some questions from people. So some was like, why does everything float in the International Space Station? They have more density than the air. That is true, but we will get to that soon. Why doesn't it go left or right? I've just covered. Somebody couldn't see the contradiction. Pardon me. The contradiction was the fact that you say there's no gravity on the International Space Station and that's why they float, but yet the International Space Station is falling because of gravity. So obviously gravity is affecting the International Space Station because they are falling, which means that they shouldn't be floating. So, and in fact, I'll actually link a video where the one lady astronaut says from the International Space Station actually says that it's like 10% less on the International Space Station, the gravity, than it is on Earth. It's like, it was 8.77 meters per second squared. So they should actually be falling faster and faster and faster and faster and faster and faster because they've been up there 20 years. So the rate they should be falling right now should be tremendous.
Stop mumbling. You know, speak up. I can't understand a word coming out of your mouth. It's just like,
Okay.
I ask you questions.
Yeah, so
I like one day where everybody was all over my ass.
somebody asked me, have I ever used an elevator before? When you go up, you feel heavier, and when you go down, you feel lighter. That's true. When you do go up, you do feel heavier, and when you do go down, you do feel lighter.
Not my dad.
But do you feel that feeling when you're going up, or do you feel that feeling when you're going down? Like right now, standing still on the floor? No. So that to me says that the Earth isn't moving up and the Earth isn't moving down.
I'm that guy.
So that says to me that the Earth is stationary. But yeah, somebody says, well, it's just a feeling. This is the thing with gravity. I've been told so many different things. That, I mean, you say we flat earthers don't agree on everything, but you globe earthers don't even agree what gravity is. I've heard so many different explanations for gravity, like gravity is feeling, gravity is weight, gravity is mass attracting mass, gravity is acceleration. I think there's a few more, but those are the ones off the top of my head. So you don't even agree yourselves on what gravity is, and they've been researching and studying it for centuries, and they still have no idea why. Even Brian Cox would admit they have no idea why or how. And after all these centuries, you would think that they would know by now. So obviously, maybe it's not correct. Maybe they're looking in the wrong place.
From the creators of the In-Betweeners.
Somebody says to me, weightlessness doesn't mean that you don't have weight, but it means that it's what you physically feel. But to that I would say, well, people take drugs and they feel weightless, or they feel they are floating and they haven't took away gravity, it's just a feeling in their head. So in that case you could assume that the weight is just a feeling in your head. Somebody asked me, why would helium expand as it goes higher? So to me, helium would expand as it goes higher because I'll link a video actually to this where pressure actually changes the shape of a balloon and the size as well of a helium balloon. So basically it would expand as it goes higher because it's starting to level out into its own density, but it's possibly also because of temperature and because of difference in the pressure.
He did it.
So I'll link a video to that as well.
Sign on the door. It says, "Do not use this bathroom. It's broken." I mean, how difficult is
Somebody
that?
says that going a certain speed can cancel the effects of gravity, since gravity is a very weak force, and that the falling of the International Space Station can easily cancel the pull of Earth's gravity,
It's too big for us.
and that if gravity was stronger than it was, then the International Space Station would fall to the Earth. The problem with that is that the International Space Station actually uses their engines every 6 months, and again that's a problem. They shouldn't have to use their engines. If they're falling, they should be going faster and faster and faster. We know if something falls on Earth, it goes faster and faster and faster the more it falls. So with the fact that they've been falling for 20 years, they should be going phenomenal speeds. And yet they don't plummet to Earth.
Homeowners insurance, a property tax.
They should have to use their engines to slow them down, not to keep them going.
You know what, from now on, I'm a mommy monk.
Gravity gives things weight. Okay, but somebody else says gravity was a feeling. This is what I'm saying. You don't even agree yourselves. What is putting everything to the Earth if the Earth is flat? Well, you can have as much massive helium as you want. It's not getting pulled to the Earth, so not everything's getting pulled to the Earth. Somebody asked me, why isn't the Earth itself falling? Well, apparently, according to the heliocentric model, it is falling around the Sun. So that's another point, actually, that brings up questions to my mind, because you say the people on the International Space Station are floating because they're falling. Well, if the Earth's falling around the Sun, then surely because we're on the Earth, like the astronauts are on the International Space Station, they're floating, so we should be floating, but yet we're not floating. So it kind of, again, contradicts itself. Also, if the International Space Station and the Earth is a ball and the heliocentric model is right, then the reason that I believe they will be falling, and I can actually link a video to this where the lady actually says this was Einstein's theory too. So basically the reason they will be falling is because they have no floor. So if you take a surface or a floor away from any object, it will fall because it has no floor. Whereas Newton says the reason things fall is gravity. Einstein says the reason things fall is because they don't have a floor, which I agree with him. It doesn't matter how dense an object is. If it has a floor, if it has something to sit on, it won't fall.
Mason, we are in the weeds out here.
I'm going as fast as I can.
Oh, I must be.
Somebody asked me, is the downward force variable depending on the medium the object is in? i.e. a bigger differential between the object's density and the medium's density equals more downward force.
You're trying, we're dying.
I don't think the density of the object really makes a difference. The density of the surrounding, the medium, I think would possibly make a difference, but I don't think the density of the actual objects does make a difference.
It is a challenge out there today, I know.
Somebody says mass slows down
But I
time.
want to share something.
Well, that's not true. You can drop two different masses and they both drop at the same time. If there's no air resistance. And the different masses, they could be big and small, and they'll still fall at the same rate.
But can you take the responsibility?
So no, I wouldn't say mass slows down time. At least not that one can see with their eye.
But I need you on the floor. Now leave the dishes. Giddy up. All right, come on. Don't let me down.
Somebody says to me about the Sunday solstice and the shortwave aerial to collect the outer band wave particles. But the problem with the outer band is that they got rid of the outer for Einstein's theory. So I don't understand how they can be collecting particles from the outer if the outer doesn't exist. Somebody asked me, why do you think you can see further from higher? So they thought it's because you're looking over the curve, I suppose. But to me, it's because you're looking for less atmosphere the higher you go. The problem with that, again, is if it was a curve and you was going higher and higher and higher, you should actually see the curve and you should see over the curve, and we never do.
People are slobs.
Well, when people ask me about you, I say that we're basically.
Somebody quoted me saying it's density times volume, which is what I said, and I said that gives you the amount of matter but not the mass. Actually, density times volume is mass, and mass is the same as matter, so according to Google anyway, so I don't really see what your point is.
All right, well, be careful when you're driving, all right? Don't be texting, don't be doing any of that. You're Obi-Wan.
Somebody says, in a vacuum chamber there is no particles of any type, so shouldn't things just levitate? No, because objects are more dense than like you said, there's no particles, which means that there's no density around it, so therefore the objects are the most dense things, so they fall because they're the most dense. So in a vacuum, there's no density in the medium surrounding them, they are the most dense, and the most dense thing falls, so no, they would not levitate.
Better friend Emily.
Is Emily a real
How does it know to seek its own density? That's a good question. Well, how does cold water know to seek hot water? How do they seek each other? How does smoke know to rise? How does heat know to rise? It's just one of those things.
I can finish mine.
Or maybe it's just one of those things that I can't explain.
I know. I mean, we're going.
Somebody says the astronauts did have a drop test on the moon, and they fell at the same rate. If you believe they went to the moon, yes. That could have been done in a vacuum chamber with that's probably why you needed the suit to breathe. But if you believe that they went to the moon, then they shouldn't have fell at the same rate, because the moon actually does have an atmosphere. It actually has neon, helium, hydrogen, methane, carbon dioxide, ammonia, water, argon-40, helium-4, oxygen, carbon monoxide. So when you think of all those particles and things that are on the moon, they should have actually caused some air resistance, at least in my opinion, especially on the feather. Somebody says put two masses of the same density but different volumes, example a 1 ounce and 2 ounce lead weight, into a vacuum chamber, and the object with the greater mass will weigh more. Yep. The object with the greater mass will weigh more because it has more mass. Mass is weight. So if something has more mass, then it has more weight. So even though they're the same density, they have different volumes, so they have different masses. So that means that one has more matter or more mass than one, and basically it's heavier. Mass is weight. Another way to think of it is you can have 10 kilograms of helium and you can have 100 kilograms of helium. The 100 kilograms of helium will obviously be more than the 10 kilograms of helium, but it doesn't matter, they'll both still rise because they're both less dense than the air. So, like, it doesn't, mass is weight. So yeah, the bigger mass will weigh more because mass is weight.
I'm sorry, were you saying something?
Yeah, okay, I know you're joking, but I mean, it's kind of true. You have to, checking your phone the whole time. So what are you really doing? You don't care what your friends are up to on Saturday afternoon, but you're also obviously not fully experiencing my profound bitching. So yeah, it's like everyone's just stuck in an in-between state, not really experiencing anything.
It's not an experience.
And also, as well, if you look at the vomit comet, when actually, they say when it's falling, that's when
So we won't be wandering the
they
streets
float
lost-
and they become
lost
whitelist.
for an hour tonight.
But if you, there's actually a video again, I'll link to this one,
Then I just texted my
and
mom
as they
back.
go up,
Oh, that's
they actually start to float. It's as they come down, they actually start to fall back to the floor of the aircraft. So
Big's family just got a miniature pet pig.
it's not really the falling that causes the floating, and also when they do go up, they end up having to stop themselves from hitting themselves off the ceiling. So technically, if they are falling, and if that is what technically is happening to the International Space Station, then the people on the International Space Station should have to stop themselves from hitting their heads off the roof.
It's room 26, yeah.
I will also link a video
It's
to
not like weird
this
that we're staying there.
International Space Station where they're doing an interview, and two women are talking, and they're on about the orientation, and how you can get confused from the ceiling to the walls to the floor. And the one lady grabs up onto the ceiling, she appears to grab something, pulls herself up,
What is he saying?
and then kicks off the ceiling back to the floor. And then within a few minutes and within the same interview, they jump through the ceiling that was magically there, and then was magically gone. This is why I have problems believing in the International Space Station actually being up there. I mean, there's clearly something the shape of the International Space Station up there, as we've seen things go over, or people have, and they've seen things through telescopes, but
It doesn't really
whether there's
matter.
somebody on it is a
You don't have to
totally
live through
different
the
question.
times after you turn 18. I mean, especially if they're not helping you financially.
That's a figure, yeah.
But I mean, living in a dorm isn't so bad. I mean, especially if it's a co-ed dorm. I mean, I've never been around like so many cute guys. at
Also,
once.
if there is no gravity on the International Space Station, which the astronauts have admitted there is, but if there wasn't no gravity on the International Space Station, then they would have no problem showing us a ball, like a big ball, and then a little ball, and throwing that over, and then making it orbit. But they can't show us that. And another problem with gravity is, when I was younger, it used to be, oh, you know, you could float in space because there's no gravity in space. And now it's changed, like, oh, there's gravity here, and there's gravity everywhere, gravity in space. So we can never actually do an experiment without gravity, which I find ridiculous as well, because you never know what basically is like without gravity, if gravity did exist. They also, on one video on the International Space Station, had this plush teddy bear that basically appeared out of nowhere. It was like a beat me up Scotty moment, and again, it just shows the fakery of it. A few more points I have was
The last step.
so I asked about
Construction site.
how if you zoom in on a building you don't see the tilt, and they say, well, a 1 degree tilt would be nothing, but the problem is there's like 69 degrees, there's 69 miles in 1 degree of the Earth's circumference. So technically, if you're saying I would be hard pressed to see a 1 degree tilt of a building, even from across the street, then
Just a few years, that's you.
why am I not hard pressed to see 1 degree of the Earth's curve, the Earth's circumference? Because like I can't see 69 miles, so why can't I see 69 miles before the Earth actually curves? You said yourself 1 degree would be hardly noticeable, so 1 degree of the Earth's circumference should be hardly noticeable and hard pressed to see.
Tenure and everything.
But yeah, apparently like dips every mile. But yeah, 1 degree is 69 miles, so I don't really understand how that makes sense.
Okay, so we have a purpose.
Hell yeah.
Oh, yeah.
Somebody asked me, well, why would they lie about the shape of Earth?
This will just be our
Well,
vibe.
there's motives behind everything, and we may never know the real motive, but the reason that I believe they lie about the shape of Earth, I believe the moon landing hoax was basically a hoax, and I think it was all set up like the space race and things like that, like it's not real, and it was just a money making scam. They thought if they can get the public to believe that there was racing to the moon and going to space and doing all this thing, then they could get the public on board. And when you think about it, it's actually a pretty good investment. I mean, you could have space agencies and you can have money every year for the foreseeable future as long as people believe it, possibly forever. Sounds pretty good to me. Yeah, it's amazing as well, because when you actually look into it, there's space agencies in like every single country pretty much. I mean, even the UK's got a space agency, and I had no idea. We don't do anything.
I don't think it's the key.
Not that I'm aware of. But if you look actually into all the countries, like I was typing in all different countries that come to the top of my head, and I was typing in country space agency, and
Basically, she's still
pretty much every country has a space agency. So when you think about all that money, year after year, decade after decade, every country after country, every country pretty much, that's a lot of money, especially when you've got people starving and homeless and they're just spending it on things like sending a probe to the sun. It's actually quite ridiculous and selfish, in my opinion. But that's my mind. Some people say if you look at all the other planets, they're all round, but that's assuming that we're spheres because they're spheres. Actually, I have a problem as well, because Neil deGrasse Tyson actually says that a planet would become flat if it was spinning fast enough. I don't know how fast that would be because he never actually says, but the planet Jupiter actually spins about, I think it was 28,000 miles per hour. And that's doesn't look flat in any of the pictures. That look perfectly round. So how fast does he have to go to actually make it flat? Because being that we're meant to be
Did Sam tell you we were
like
stay here?
an
No.
Sorry.
an ob
She said you were.
oh, what is he?
Yeah.
My mind's gone blank.
Just got back.
Being that we're meant to be, I think of Big True Future. Welcome to this oblate spheroid. Oblate, yeah. Okay, so it's meant to be an oblate spheroid, meaning that it's flatter in the middle, so it's a bit squished. So if we're a bit squished, then Jupiter should be a lot squished because it's going like 28 times faster than us.
Come back
Yeah.
a little bit.
Yeah, we have to get out of here.
Basically, also, I had some problems with Simon Dan because he was trying to tell some flat earther that the reason that clouds form is because of little droplets floating on the buoyancy of the air, and he was on about condensation, but it's not condensation that makes clouds, it's evaporation. So I just like to clear that up for Simon Dan, that it's not condensation. Condensation and evaporation are two different things. And if you think water droplets are that tiny that they can just float on the buoyancy of air, then I challenge you to go outside and, you know, get some little droplets of water on your hands and flick them everywhere, and you will see puddles on the floor. Like, you won't see any droplets of water floating on the buoyancy of the air. I'd just like to say. So.
Yeah, where you have to fend for yourself.
Yeah, that's a good idea.
Yeah. Well, how are you feeling about it?
Excited, kind of excited, terrified.
Yeah, kind of that voluptuous panic.
So yeah, I think that's about everything.
I liked college a lot better than high school. Kind of find your people in college, you know?
Oh, and people says that they didn't have the technology to fake the moon landings, but the moon landings was in 1969, and Mary Poppins was in 1964, which was 5 years before. And if we look at the visual effects for that, that was pretty good. The Wizard of Oz had visual effects, and that was in 1939, which was like 30 years before the moon landing. So you can't say that they didn't have the technology or the special effects to do something like that. If they can make a floating nanny fly through the air, or a magical Wizard of Oz. So
She's my best friend.
yeah, I'd just like to point that out.
Take it up with her then.
So let me know your thoughts. I would appreciate it. Those are my thoughts. So I'll link those videos as well, so that I can help you see and understand what I've been seeing, so you can maybe get my perspective on why I think that. Just like to point out that the very first boat that they've known to have existed was 8000 BC. That was way before any time that gravity was around. They managed to make boats float without gravity because it's pretty much common sense. They didn't need gravity to make a boat float, so that just proves you don't need gravity. I think I proved mass doesn't attract mass. Like I said, you can have as much helium as you want and it will not be attracted to the mass of the Earth. So these are some of my thoughts.
I don't regret anything.
Hope you have a good day or night wherever you are, and take care and stay
That's a
safe.
relief not to have to be around